Now, so far in this lesson, we've talked about deliberate fraud, unconscious biases, we've talked about stuff-ups, mistakes, all of which can make science that doesn't reproduce, and we've seen that a large fraction of science, at least in some areas, does not reproduce. But now I'm going to be a bit controversial and say there's another problem which maybe is even worse than everything we've talked about so far, which is science that does reproduce, therefore is technically formally correct, but is totally bloody useless. Now, this is a recognised problem, but has received nothing like the attention of the previous things we've talked about. So in this section I'm going to go somewhat controversial and somewhat inflammatory and use examples from my own experience. So please, what I'm saying here would not be agreed by many people. I'm just trying to flag something I think is a major issue and get you thinking about it. So there are two reasons we're talking about here, and one is the idea of dead subdisciplines. A subdiscipline is an area of research, and there's a sort of dynamic behind subdisciplines. What happens is a new technology or a new result indicates that there might be something exciting. Everyone floods into the discipline and starts doing research. It could be like the discovery of the first exoplanet. Everyone decided exoplanets is really great. Right now we're in an AI boom. Everyone thinks AI is great. So there's some breakthrough, some new result, and some particular area of research suddenly becomes very trendy, and people flood into it and start working. Very early on you get a whole string of very big results. But then, very often, progress slows down. Maybe the big results have already been worked out. People have discovered the major clues or whatever it might be. So in principle, okay, that was exciting. We've discovered the main feature. Everyone go off and work on something else. But that's not what happens. Because a lot of people have now spent a large chunk of their career working in this field. They've got a reputation for working in that field. They've trained up graduate students and postdocs to work in that field. And they're going to keep working in that field. It's very hard for scientists to change their research field completely. So they persuade themselves that it's still important and still progressing. Of course, progress never entirely stops. There's always more things being discovered, and it's a gradual downward slope. So maybe like a frog in boiling water, gradually it becomes less and less exciting, but people always convince themselves it's so exciting. And so the whole zombie field can keep going for decades and decades, even centuries. The people working in this field will train PhD students who will then go on and become new researchers in this field. They will sit on grant allocation committees and make sure that research in their field gets grants, because clearly it's very important. An example is a field I did by PhD in, unfortunately, which is the research in quasars. Quasars are giant black holes in the middle of galaxies, and when they were first discovered back in the 60s, it was incredibly exciting. They were the brightest, most powerful, most violent things in the universe, and were a key test of the evolution of cosmology and the origin of the Big Bang. But rather rapidly, within the first 5 or 10 years, people basically figured out what they were. They figured out that, yes, they are large black holes squirting out jets, an accretion disk around it, and they figured out the effects of cosmology. Since then, lots of people still work on these things. They've worked out different subcategories of quasars, so-called active galactic nuclei, and they've divided them ever more finely. They've tried to work out the exact details of how they interact and are fed and so on. But in some sense, the really big question, what are they? What do they matter for the origin of the universe? Was answered quite quickly. But decade after decade, more and more people have filled in the finer and finer details, including myself. That's my PhD thesis. And is it really interesting? I mean, we know these things are giant black holes. When I give a public talk, I'll say it's a giant black hole. I'll talk about the accretion disk, and the fine details of exactly what's causing the accretion disk to work really isn't that interesting to most people. And it's of no practical application. Perhaps the biggest example in physics, I would say, and here I'm being very controversial, is grand unification theories. These are the theories of everything that unify gravity and quantum mechanics. Einstein was one of the first people to work on these things, and for generation after generation, the brightest young scientists have gone in to try and come up with a grand unified theory of everything that explains the entire universe. And they failed, over and over and over again. There's been a huge field of research where many of the brightest theorists have gone into it, and I don't think it's produced anything useful. It's produced a lot of very esoteric mathematics. We've no idea whether any of it's true, but no practical applications whatsoever. And even the esoteric mathematics is incomprehensible even to most physicists, let alone the general public. So you can claim it's a human curiosity, but who? Curiosity of a few extreme theorists. This is again an example. This approach, unification, worked for Maxwell, it worked for Einstein, and it hasn't really worked very much since, at least not for the last 60 years. People still haven't abandoned it. Well, a lot of people have abandoned it. There are lots of reformed theoretical physicists out there who've gone into other more useful things, but a lot of really smart people keep throwing away their careers on working on this whole thing. So it's always careful. A field of research, just because lots of people are working it, doesn't mean it's interesting. It could just be that it was interesting at some point in the past and the inertia has kept people still working in the field. So that's one example of how you can get relatively uninteresting science. Another example is another research field I've published in, which is education research, which I'm very disillusioned about. So once again, I'm going to be very controversial here and go for the jugular. Now, education research, trying to improve education. There are several hundred education research journals, and it's the total number of education research papers published is in the tens of thousands, maybe even the hundreds of thousands per year. So there are at least many tens of thousands of papers published every year reporting ways to make education better. Now, a lot of these papers are literature reviews and opinion pieces and so on, but a lot of them are also decent attempts by well-meaning people to find ways to make education better. But we've now had probably 1 million papers on improving education over the last 30 or 40 years. Has education got any better? Well, people have tried doing things like putting current students through standardized testing from the 1960s and so on, and by and large, the students today do no better than the students on the same test from a long time in the past. There's actually no evidence that teaching and education has got better. Or worse, I mean, there are small trends from year to year in particular things, but by and large, the level of education today is very similar to the level of education from decades ago. But if you take all those papers, add up all the papers that say this technique gives a 10% improvement, that technique gives a 15% improvement, add up all those percentage improvements, we should be thousands of percent better by now. We should be able to teach a 3-year degree in 2 months. If all that was true, we should be able to finish, teach people to calculus before they've got out of year 3. But we aren't. By and large, education, maybe it's got a little better, maybe it's got a little worse, but no great change despite all this incredible volume of tens of hundreds of thousands of papers of research. So many people have devoted their entire life to research and apparently made no difference. So what's gone wrong? Well, there's a lot of possible theories about why this huge amount of education research has made rather little difference. The most optimistic idea is, in fact, we have got much better techniques for educating, but the students have got much worse. Maybe they broken homes and COVID and drugs and young people today, terrible bunch. I don't think that's at all plausible. Another theory, which is certainly partially true, is that education has improved, but that just allows the students to do less work. This is absolutely true in universities. Students are getting the similar grades in universities today than they were decades ago, but the average number of hours worked for a university student today is dramatically less than the average hours worked by a university student 20 or 30 years ago. Which is still a good thing. Students can have more spare time. Of course, given the expense of living, that means students can maybe work to pay their way through university, but it's rather dispiriting. It could be that this research, if people actually applied it, would give you this amazing improvement in education, but no teacher has time to read tens of thousands of papers, so most teachers are completely unaware of all this research, and so it doesn't actually get implemented. And there's a lot of truth in that as well. It could be that the research is just crap, that all these publication biases and unconscious biases mean that most of these papers are bullshit, and there's a lot of truth in that as well. But there's a final point, that in education research, a lot of the research is too specific and cannot be generalized. Let's say, for example, you're trying to work out whether having interactive discussions improves learning of physics. So you might take 2 groups of physics students and try interactive learning for one and non-interactive learning for the other, and then test them at the end, and you find that it makes things better. Okay, but what that tells you is for that particular cohort of students in that particular university on that particular study, it does this. People often interpret it as saying interactive education is good. Interactive education might work for them, but it might not work for the same class the next year. It might not work for the same class in their maths. It might only work for some of the same class. It might not work in biology. It might not work in year 12. A lot of the results can be so specific to a particular niche that they don't translate. So people talk about the grand laws of education, like interactive is better than passive. These things don't graduate. A situation like education, much like psychology, things are very specific to the particular people you're doing it at. So there's a lot of value, I would say, to an individual educator trying different things, but can they really learn from something that was done at a different university to a different cohort of students? Maybe not. So why is such an enormous volume of apparently useless research published? Well, education academics are mostly employed not to do research, but to teach new teachers or to meet certification requirements to have well-educated university lecturers. But because they're at a university, they feel that they have to do research. Once upon a time, education researchers are mostly at teacher colleges. They were former teachers, and there was no expectation there to publish research. But now all those old teacher colleges have become folded into universities. They're now expected to be academics, and they're expected to have PhDs, and they're expected to publish research. And in a university environment, if you don't publish research, if you just teach teachers, you're not going to go very far. You're not going to get promoted, you're not going to get grants, and so on. So they feel they have to publish, and the university wants them to publish, because the more publications come out of the university, the higher the university goes up in the rankings, the more money the university gets. And their papers, when they publish a paper, it's refereed by other people in the same situation. So you've got this whole mass delusion that this is all useful and worthwhile. No one actually really cares the research is actually useful. They probably do at some level, but the most important thing is to publish so you get promoted, publish so your university looks good, publish so the discipline keeps going very well. So you can easily get whole fields of research publishing useless papers which are too specific and which don't actually help anybody, but sustain the whole thing over generation after generation. Sad.